Hello, my name is Toklo, but you can call me Sir Protocol. In this video, I will be talking about differentiation using the power rule. That is how we can differentiate a function with the help of the power rule. Differentiation is the process of finding the derivative of a function. The question now is, what is the derivative of a function? Derivative of a function is the slope of the graph of the function, or is the slope of the tangent line at a point. Let's consider a function. Say y is equal to x squared. If I'm to sketch the graph of this function, I'll be having something like this. So this is my y-axis, and this is my x-axis. So my x-axis, my y-axis. So this is a parabola which opens up on y-axis. So if I have a tangent line, so this is a tangent line. Okay. So we are saying that the derivative of this function is the point where the tangent line touches the curve. So this point is what we are talking about. So in this tutorial, we shall be looking at how to use the power rule to find the derivative of a function. Okay, that is the purpose of this video. So let's consider a function. So we have y is equal to a(s) exponent n, where a is a constant, s is a variable, and n is also a constant. Now, how do we use the power rule to find the derivative of this function? Using the power rule, the derivative, which is also called the slope or the gradient, will give us dy dx equals, using the power rule, the n will multiply this. So we'll be having n a s, and we shall subtract 1 from the exponent. So we have n minus 1. So what you have here is the power rule that we shall be using to find the derivative of a function. Let's begin with some example. Let's begin with some example. Example 1. Y is equal to 4x to the second power. Using the power rule, my dy dx, which is the gradient, will be equal to, so the exponent, which is 2, will multiply 4x. This will give me 2 times 4 subtract 1 from the exponent. So 2 minus 1 will give me 1. If you like, you cannot write this 1, so I decided not to write it. So I have 2 times 4. So finally, I will have 8s. Let's talk about the second example. Example 2. Example 2. Okay. Y is equal to 6s to the 4th power. Using the power rule, my dy dx will give me 4 times 6, 24s, and we subtract 1 from 4. So we have 3. The next example. The next example. We have y is equal to 2/3 s to the 3rd power. Please, you can pause this video and try this work on your own before you come and have a look at the solution. Okay, so use the power rule. My dy dx will be equal to 3 times 2/3 s to the 2nd power. I believe you have gotten the pattern now. So we have this to be equal to this 3 will take away this 3. So I'll be having 2s to the 2nd power. Let's try another example. The next example. We have y is equal to s to the 5th power minus 2s to the 4th power plus 3/2 s to the 5th power. No, to the 3rd power. Okay. So we now have dy dx. Using the power rule, we have 5s to the 4th power minus 8s to the 3rd power plus 3 times 3 divided by 2. Okay, it's like this. 3 times 3/2 s squared. Finally, I'll be having 5s to the 4th power minus 8s to the 3rd power plus, so 3 times 3, I'll be having 9/2 s to the 2nd power. So this is the answer for this example. Now, let's look at how you can use the power rule to find the derivative of a constant. So let's try. We have given y is equal to 5. Let's say you are having a function like this. Y is equal to 5. And you have to use the power rule to find the derivative of this function. Okay. But we know that any number exponent 0 is equal to 1. Therefore, if I have s exponent 0, I'll be having 1. Y exponent 0, I'll be having 1. 4 exponent 0 will be 1. So anything exponent 0 is equal to what? 1. It means that I can write 5 as 5 times s exponent 0. Why? The whole of this we know is 1. Therefore, this is the same as 5 times 1, which will give me 5 as I have here. So we are saying that 5 can be written as 5 times s to the 0 power. Okay, so with that knowledge, we can rewrite this function as y is equal to 5 times s exponent 0, which is the same as y is equal to 5 s exponent 0. Now, using the power rule, my dy ds will be equal to, so the exponent, which is 0, will multiply what? 5. So I have 0 times 5 and x. So 0 minus 1, use the power will be negative 1. So my dy ds my dy ds will give me 0 times anything is equal to 0. So anytime you differentiate a constant, you always get 0. For instance, let's say we are having a function to y is equal to 10. Then my dy ds will be equal to 0. Another function, y is equal to pi. My dy ds, pi is constant, will be what? 0. We have another function to be y equals 4 pi. My dy ds will give me 4 is a constant, pi is a constant, so I'll have what? 0. Therefore, anytime you differentiate a constant, you always get 0. Let's try some example to see how you can use this. We have y is equal to s plus 2 over s squared plus 3s exponent 2 plus 15. And then make it negative minus 3. But we know that 2 over s squared is the same as 2s exponent negative 2. So let's rewrite that. Y is equal to s plus 2s exponent negative 2 plus 3s squared minus 3. Hence, my dy ds will give me 1. If I differentiate this, I'll get what? 1. 1 minus, because negative 2 will multiply 2, so we'll have negative 4. 1 minus 4s exponent negative 3. Negative 2 minus 4 is negative 3. Plus 6s. If I differentiate this one, I'll get 0. So minus 0. Finally, I'll be having 1 minus 4 over s to the third power plus 6x. So this is the answer to the last example in these two Thank you so much for watching this tutorial.